Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I am going to discuss a very famous and important and very GS topic that is known as a surface integral. Surface integral. Surface means area. Area means any region. Any region is given to me in our question, and we want to calculate an integral along any region. Then we find integral, surface integral. In last lecture, we have discussed in detail what is line integral. When we evaluated the value of any integral along any given curve, then that value is known as a line integral. That integral is known as a line integral. What in this topic we want to evaluate of any integral along any region, along any surface, then that integral is known as a surface integral. So main concept of the surface integral, we want to evaluate the value of integral along any surface, then that is known as a surface integral. So how we can calculate a value of a given integral along any surface? So in this question, in this topic, in question, we have given 2 points. First is integral. Integral is given, evaluates the value of this integral. And surface is given. Then we evaluate the value of the given integral along the given surface under some conditions. So we start to solve the problem. Now first, what is definition of surface integral? I have already discussed about this. Any integral which is to be evaluated over a surface is called a surface integral. In last lecture, we have discussed and solved some problem on any integral which is to be evaluated over a line is called a line integral. Here is surface given. We want to evaluate an integral over a surface is called a surface integral. To find the value of the surface integral, we apply the following formula. So which formula we apply here? Here apply here formula number 1. This is given by number 1 formula. So here double integration, that is given region R. R is any region or surface. We can say this is surface. Surface. This is vector point function, and this is an unit normal vector, and ds is the surface, f is the vector point function. Now this convert into double integration. This is region R, f dot n, ds, value of ds is here dx into dy upon mod k dot n, k vector and dot n vector. This is the value of ds. So in every question, if in surface integral, we apply formula number 1. This is very famous formula. After proved, we find out this formula, and in every question, we apply this formula to find the surface integral, value of the surface integral, or evaluated of any integral over a given surface. Problem 1, we want to solve here problem 1 based on surface integral. That is very most important problem. Very most important problem, and very easy. I want to discuss the solution of this problem in easy way. how we can make a solution of this problem in easiest way, in the easiest way. So what is problem? Problem this: evaluate the value of this integral. Integral is given us double integration under the surface, is any vector point function is given in our question, the value of vector A, and is unit normal vector, unit normal which is perpendicular to the given surface. Unit normal vector is that vector which is perpendicular to the given surface. Suppose surface is this, then unit normal vector is this, perpendicular to this surface. That is known as a unit normal vector. Suppose this is surface and this is unit normal vector. This is perpendicular to the given surface. So any surface is any type of surface. Surface is this. So unit normal vector is this. Direction of unit normal vector in with respect to a surface is change. If surface is horizontal, then the unit normal is vertical. If surface is inclined surface, then unit normal vector is also inclined vector to the horizon. So we want to calculate here the value of this given integral in our given problem, where a vector is vector point function. This is given by this x plus y square into I cap minus 2x j cap plus 2yz k cap. And S is the surface of the plane. Here plane is given. Surface is a plane. 2x plus y plus 2z equal to 6 in the first quadrant. Please understand the problem. Again, totally solution of this question is given in our problem. Totally solution. You read 2 or 3 times the problem. What is the problem? Problem is this: in our problem this integral is given. Which integral given? Integration under the surface as here vector A and dot n is unit normal vector and into ds. We find out this value. What here A vector is given is known, 100% known. Vector A is known and n normal vector. This is to find. इसको find करना है. This is find. You have to find unit normal vector and value of the ds. ds equal to dx into dy into k dot n. This is value of ds. So here start the solution. What is solution of this problem? We know that a vector n is any vector that is not normal, which is normal to the given surface. Any vector that is represented by vector small n. Vector small n is normal vector. So how we can find a normal vector? If any surface is given, suppose surface is given by f. F is any surface. Let f is any surface. Let f is any surface is given in our question, that is represented by f. Then del f is known as a normal vector to the given surface. So here f, this is surface, plane is a surface here. 2x plus y plus 2z equal to 6. 2x plus y plus 2z equal to 6. This is the plane. Here the type of surface is plane. Plane is given here. Equation of plane is given here. So this is represented by f. What is f? F is plane. We know that a vector n Vector n is normal vector to the given surface, which is normal to the given surface. F equal to 2x plus y plus 2z minus 6 equal to 0. This is the plane F, surface F. Is given by vector n is equal to del F. Del is vector, F is scalar. That is known as a grade F. Grade F known as a directional vector. Grade F is directional vector, which is the normal to the surface. Directional vector. Direction of this vector is normal to the given surface. So surface that is known as a del F. F is 2x plus y plus 2z. Minus 6 always be 0. So I am not taking here minus x. Now putting the value of del. This is the value of del. I dou over dou xi plus dou over dou yj plus dou over dou zk. This is the value of del. And this is F. F. Surface. Surface is 2x plus y plus 2z. Here I am not writing 6. If you are writing 6, then there is no mistake. Minus 6. Okay. Now, n vector n cap. N cap vector. Cap. Any vector. Suppose n is vector. This is normal vector. If I am writing n cap, this is unit normal vector. N cap is a unit normal vector, which is normal to the surface S, is given by the following formula. This is very important formula and very interesting. So n vector is del F. Del F is n vector. So unit normal vector, any vector converting in unit normal, unit vector, if we divide by its mod, any vector is given, suppose n vector is given, n cap equal to n vector and divide by its modulus. N vector divided by its modulus, that is n cap. N vector is del F and mod del F. So what is del F? Dou over dou x of 2xi. So now del F, we have found del F last slide. Here dou over dou xi, dou over dou yj, dou over dou zk. Similarly in this function, 2x plus y plus 2z minus 6. So now this function taking with this, differentiating with respect to x to this, with respect to y to this, with respect to z to this. After differentiating, we get result this. With respect to x, y, z are constant. So here only 2x. With respect to y, x and z are constant. Only here y. And with respect to z, x and y are constant. So here only 2z. Similar same terms in denominator. So we write here, this is n cap, unit normal vector. N cap is a unit normal vector. Unit normal vector, which is perpendicular to the given surface. Perpendicular to the given surface. To the given surface. So now here differentiating of 2x with respect to 2y. With respect to y of y is 1j. 2z with respect to z is 2k. And similarly in denominator 2y plus j plus 2k. Now this is modulus. Modulus of this vector. So next term is n cap vector is 2i plus j plus 2k upon, taking modulus of this lecture. Modulus, coefficient of I is 2, coefficient of j is 1, coefficient of k is 2. So how we can find modulus? Modulus of 2i plus j and plus 2k, this equal to under root I का कोफिशिएंट 2 का स्क्वायर प्लस 1 का स्क्वायर एंड प्लस 2 का स्क्वायर. So this is under root 9. This is 3. Okay. So now we get this under root 2 का स्क्वायर plus 1 का स्क्वायर plus 2 का स्क्वायर. So under root 4 plus 1 plus 4. So this 2i plus j plus 2k under root 9, 2i plus j plus 2k upon 3. So now unit normal vector, unit normal vector, unit normal vector, this n cap is equal to 2i by 3 plus j by 3 plus 2k by 3. This is equation 2. First of all, in our question, surface is given, and then we find out a vector which is normal vector. First of all, we find out the normal vector which is normal to the given surface. Then that is the formula is, we have applied here, formula is n vector. This n vector equal to del f. This is the formula, grade f. F is a surface and del f is grade f. Grade f means directional vector which is normal to the surface. We find this n vector. After finding n vector, we find out the unit normal vector which is also perpendicular to the given surface. Unit normal vector means that vector whose modulus is 1. After taking modulus of n cap, then we find the value of 1. Modulus of n cap is 1. Modulus of n cap always be 1. Because n cap is a unit normal vector. Unit normal vector. So we find here n cap. N cap is 2i by 3 plus j by 3 plus 2k by 3. Modulus of this vector is 1. So modulus of this vector is 1. Now next point, we find out here k dot n. How we can find k dot n here? What is the region k dot n? Our surface is xy plane. So xy plane perpendicular to. So now apply here k vector and n vector. K vector, n vector is this. So k dot n is 2 by 3. Value of k dot n is 2 by 3. Now apply formula. We have discussed formula which is given in our question. This is integral, value of the integral. Double integration as under the surface as a vector dot n cap vector into ds. This result equal to double integration as a vector dot n vector and value of ds is dx dy upon k dot n. This is equation 1. Now first of all we find out a dot n cap, a vector dot n cap. So a dot n cap, we apply the formula here. This equal to value of a x plus y square I minus 2x into j plus 2 by zk. This is the a vector. N vector we have find just now n vector, n cap vector. So 2i by 3 plus j by 3 plus 2k by 3. Taking dot product between these two vectors. Vector a vector and vector n cap. Unit normal vector. A vector is given in our question. N vector we find out. N cap vector. And taking dot product between vector A and unit normal vector A n cap. Because these two value is given in our question, in our formula. So here we find out this I to I. So 2 by 3 x plus y square, I to I multiply j to j and k to k. In dot product, we multiply in same vector, I into I and j into j, k into k. Other different vectors are 0, I into j 0, I into k 0, j into I 0, j into k 0, k into I 0, k into j 0. So other dot product are 0, only similar vector dot product is 1. So we are multiplying in same vector, I dot I. So I dot I is this, minus 1 by 3 is 2x and 2 by 3 into 2 by z. This is the value of A dot n. After multiplying this, 2 by 3x, 2 by 3y square, minus 2 by 3x and plus 4 by 3 by z. So this term is cancelled. Now remaining term is A cap, A vector dot n cap equal to 2 by 3y square plus 4 by 3 by z. This is equation 4. Now in our given surface, 2x plus y plus 2z equal to 6. Find out the value of z. 2z equal to 6 minus 2x minus y. Z equal to 6 minus 2x minus y upon 2. So this z remove from equation 4. Putting this z here. Then we get here putting in 4 from equation 5, putting in 4. A vector dot n cap equal to 2 by 3 y square and plus 4 by 3 y into putting value of this z. Z is this. Z is this equation 5. From equation 5, putting in equation 4. From 5, putting in equation 4. 2 by 3 y square plus 4 by 3 y, 1 by 2, 6 minus 2x minus y. This is equation 6. After multiplying here, 2 by 3 y square and this 2 is cancelled. So 2 by 3 y into 6. 2 by 3 y into 6 means 4y. 3 2 is 6 and 2 2 is 4y. 2 by 3 means 4 by 3 xy. And here 2 by 3 y square. Y into y square. So now this term and this term is cancelled. 4y minus 4 by 3 xy. So now 4 by 3 is common and y common. So 3 minus x. This is equation 7. Clear? I repeat this topic again. A vector dot n cap. A vector is, we have product, get this. Now here is z value. Z. So z is converted in x and y. So this is the surface. From surface, given surface, we get value of z in equation 5. From 5, putting in equation 4, value of z. Then we get this result. After simplifying, we get equation 7. Now apply formula. Double integral as a cap dot a vector dot n cap into ds. This equal to double integration under surface as a vector dot n dx dy upon k dot n. So now this is the formula, putting value here in second integral. So here double integration r. This is convert in region r. R is given any surface. So 4 by 3. This resulting from equation 7. Putting from equation 7. 4 by 3 y 3 minus x. And this is the dx dy. This is k dot n is 2 by 3. 2 by 3 means 3 by 2. Here k dot n is given 2 by 3. After putting here this, then this is reverse. 3 by 2 dx dy. So 3 is cancelled and 2 is cancelled. 4y3 by 3 minus x, 3y2 dx into dy. So here now, here 2x plus y equal to 6 and z equal to 0. How this result? Here plane is given 2x plus y plus 2z equal to 6. So in this plane, putting z equal to 0. After putting z 0, then this surface converts in 2x plus y equal to 6. Means y equal to 6 minus 2x. 2 is common, means 3 minus x. Okay. So this is the value of y. Minimum value of y is 0. Maximum value of y is 6 minus 2x. Now putting here y 0. Minimum value of x is 0 and maximum value of x is 3. So these are the limits. Limit of x and limit of y. Y is minimum 0, maximum this. X is minimum 0, maximum this. And z is 0. So now here double integration under s, a dot and ds, we have value this from here. Now this double integration 0 to 3, limit 0 to 3, limit 0 to 6 minus 2x. This is the 4y3, y into 3 minus x and 3y2 dy dx. Now, value of this integral equal to 0 to 3, 0 to 3 minus 2x, here 4y3. This is 3 minus x, 3y2 y dy. 3 is cancelled here, 2 is cancelled too. So we get here 2 into 3 minus x. Now, integrating of y dy, this is y square y2 and apply limit 0 to 6 minus 2x. So here writing 0 to 6 minus 2x. So now 3 minus x, 2 into 3 minus x, 2 into 3 minus x and here 6 minus 2x का whole square minus 0 dx. So here 4. How we get here 4? 2 is common here. 3 minus x and 3 minus x का whole square. 2 is common from this bracket. 2 to the 4. So 4 to the 8 here. No, 2 is cancel here. So not 2 there. 4 only. This is correct. So here 4. 3 minus x का cube and minus 0 dx. So 3 minus x का 4 upon minus 4 integral of this 3 minus x का whole cube dx. This equal to 4 times 0 to 3 minus x का whole cube and dx. So we get 3 minus x to the power 4 upon 4 and minus sign. So 4 is cancelled, putting 0 to 3 limit. First of all, putting upper limit x equal to 3, then this result is 0. Lower limit 0, then 3 to the power 4. So here is minus sign and here is minus sign, minus 1. Here is minus 81. So total result is 81. This is correct answer. So this type of procedure, we can find the value of any integral under the given surface. Okay. Now we want to discuss problem 2 based on surface integral. This is same problem. Surface is changed and vector A is changed. Other is no change. So we find out the value of evolutes double integration under the surface as vector A is given, n cap we have to find and ds we have to find. Only two value we have to find here, n cap. How we can find n cap? And ds. What is the area of surface? ds. Where a is given here in our question. A zi plus xj minus y square z k. This a is given here. K vector is zi cap plus xj cap minus y square zk cap. This equation is given. Vector A is given and surface is also given. F is surface. F is x square plus y square minus 16. This is equation 2. Surface given and vector A given. And limit is given in first obtained between limit is z equal to 0 and z equal to 5. This is limit. So solution is start a vector n vector. Now we find out the value of n vector which is normal vector to the given surface. S is given by n vector, this equal to del f. We have find out in last problem del f, value of del f. So now n vector del, this is f. Value of del, find out the value of del. We have already discussed del I dou over dou x plus j dou over dou y and plus k dou over dou z. This is the value of k cap. This is the value of del. So now putting the value of del here, this, and this is the surface. So now this taking with respect to x, differentiating with respect to y, with respect to z. So dou over dou x of x square plus y square minus 16 into y plus dou over dou y x square plus y square minus 16 into j plus dou over dou z x square plus y square minus 16 into k. So here no z, in our surface there is no z value. So differentiation of this result with respect to z is 0. Dou over dou z x square plus y square minus 16, this result 0. Because here is no z. This is free from z. So all constant are there. X is constant with respect to z, y is constant with respect to z, and 16 is number already constant. So differentiating first with respect to x, we get 2x, 2xi. This is wrong. 2xi cap. And with respect to y is 0, j and 16. Here with respect to y, 2yj. But we know that n cap is a unit normal vector to the given surface S. Unit normal vector to the given surface S, that is n cap. N cap find out n vector upon modulus of n vector. So n vector is del f. So divide by mod of del f. 2xi plus 2yj upon modulus of 2xi plus 2yj. So 2 is cancelled after taking common, 2 is cancelled. Xi plus yj upon mod, this is xi plus yj upon mod xi plus yj mod. Mod of this under root x square plus y square. This is equation 2. This is n cap. Now let R be the projection of S on yz plane. Projection on yz plane, then we get here y and z projection. So perpendicular to yz is I. So we are taking here, this is the formula. This is formula evaluating of an integral under any given surface. So region are bounded by y equal to 0, y equal to 4 and z equal to 0, z equal to 5. How we can find this result? So here surface is given x square plus y square equal to 16. First of all putting y equal to 0, x equal to 0. Then we get y equal to plus minus 4. So y equal to 4 and y equal to 0. and z equal to 0, z equal to 5 given in our question. So now I dot n, I cap dot n cap. I dot, this is the value of n cap. I dot I only. So we get here x upon, this is the 16. X square plus y square equal to 16. This value putting here. So this is xy4. I dot n cap. I cap dot n cap. This is xy4. Now finding a vector dot n cap. So a vector is this and this is n cap. Now taking dot product, I to I means zx and j to j means xy, plus other result is there is no k. In second vector there is no k vector, 0k. So this result multiply this 0. We get only zx plus xy upon under root x square plus y square. So here x square plus y square is 16. This value putting here. So x is common. Z plus y upon 4. This is a vector dot n cap. We find out the value a vector dot n cap. In our question we find only two values. A vector dot n cap and value of ds. Value of ds is dx into dy upon I dot n. I cap dot n cap. I dot n cap. I dot n cap dot. I dot and n cap. This equal to xy4. We find out this value. Now all value putting in our integral. Then we find this is integral. Double integration in region R. A cap, a vector dot n cap, dx dy upon I dot n. This equation. Putting value this result. We have find 1 by 4 in last equation, this 4 from equation 4 putting in 1 from equation 4 putting in 1, then we get, so here a vector dot n cap, this equal to 1 by 4x y plus z, dx into dy. What is I cap dot n cap? This value is xy4. So here putting xy4. This is cancel. I am putting here xy4. This is converting 4 upon x. So I am writing here 4 upon x dx dy. So 4 is cancelled and x is cancelled. We get here y plus z dx dy. Okay. This equation is 5 and this 6. Now next, integrating this here. First of all integrating with respect to y. So double integration y is 0 to 4 and z 0 to 5. Any we can integrate. So here y plus z and dx by, not dx, dy dz. Yeah, dy dz. Dy dz, not dx. Dy dz. So here is integration dy and dz. So integration with respect to z. So this is yz and plus z square y2 and putting 0 to 5 integration 0 to 4 and here is dy. Integration with respect to z here yz plus z square y2. So putting this value here, double integration here y plus z dy into dz. So first of all is 0 to 4 and 0 to 5. So integrating with respect to y, 0 to 5, y square y2 and plus z y. Apply 0 to 4 and here dz. Now this equal to here, putting limit 16y2 4 and plus 4z and dz, integration 0 to 5. So now again integrating this, 8z plus 4z square y2 and putting limit 0 to 5. So here 8 into 5 and plus 4, 5 ka square y2. So here 40 and here 2 ja cancel this. So we get 2 into 25. So 40 plus 50, this equal to 90. Okay. This is the value of the given integral. Here age mistake is this, integration 0 to 5 and here dz. Okay. This is correct line. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.